Okay, now in a smooth pulley system, a force F is required to bring an object of mass 5 kg to a height of 20 meter at a constant speed of 3 meter per second as shown in this diagram. Determine the force F and the work done by the force F. Okay, good. I focus on this word, this keyword, constant speed. Why you say constant speed? The speed is constant. Acceleration is 0. Okay? So this means a lot. Here, this means a lot. First, it means this object, this object is equilibrium because the speed is constant. Acceleration 0. Equilibrium. So the first thing about equilibrium, you can say total force equal to 0. Total force equal to 0. Another thing is about equilibrium, constant speed. That means the net work done also 0. That means the change of kinetic energy also 0. Because there's no change in velocity, the speed is constant. So the change of kinetic energy is 0. The net work done is 0. So here we can use the work energy theorem. You see that? Work energy theorem, the net work done equal to the change of kinetic energy. In the end is equal to 0. Now the net force also equal to 0. Actually, you can write it as you can write like this. Net force is 0, or some people write as sigma F equal to 0. Okay? The net force equal to 0, the net work done also equal to 0. Change of kinetic energy is 0. Okay, this is the first thing you should know about this. Now, we should draw a free body diagram for the block. Okay? Let's draw the free body diagram. Okay, you look at here. First, we identify what kind of force exists for this block. So, what kind of force exists for this block? It has the force F here going down. So, actually, this block, it has the tension going up, isn't it? Force going down, and then force going down. So actually this force is the tension. This tension is actually the force. This tension is equal to the force. You can write this as tension, or you can write it as force also. And then also it has mg, the weight. So okay, let me draw the free body diagram. So this is the block. I put a dot mass there, and this is I put it as force F, or you can write it as tension. This is the weight, weight mg, and then acceleration is 0. Okay, acceleration is 0 because no acceleration. One thing is because we are focusing on work done, isn't it? Work done. So we are focused on the displacement, direction of displacement, because our formula work done has displacement. We need to find the angle theta. So we need the displacement to compare with the force to get an angle theta. So we need to draw the displacement direction. So displacement direction is going up. Sorry, is going up. This is the displacement direction. And it displays to a height of 20 meters. So that means from the ground go to the height is 20 meters. So you write this as 20 meter. Alright. Now let's continue. I want to find the force F. Okay, force F, very simple, because this is equilibrium, isn't it? So go back to your chapter forces. Forces. You look at the y component, because it say constant speed, acceleration 0. So we can say it's equilibrium. It is equilibrium. Equilibrium means total force in the y component is 0. Total force in the y component is 0. Okay, equilibrium. Yeah, just put the word equilibrium there. Right, equilibrium. Yeah. So equilibrium means total Fy equal to 0. So now how? Okay, so we just put direction going upward is positive, going down is negative. So the force F is positive, the mg is negative. Let's put that. So F and then negative mg. Negative mg equal to 0. So your F is equal to mg. So your mass is 5 kilogram, right? So 5 times 9.81. So what's your answer? What's your answer for force F? Let's calculate. Okay, it is 49.05 Newton. Okay, 49.05 Newton. I got the force already. Yeah. Okay, question B. Okay, so just now I applied already the first concept about equilibrium. Okay, I use the net force equal to 0. Yeah, in this condition, the total force in the y component is 0. Yeah, I already applied the first concept. Sorry, I already applied the first concept. Okay, the net force is 0. So I got the force F. Yeah, actually the force F is equal to the mg. Okay. Now, for the B, work done by the force F. Okay, work done by force F. So how? Work done by force F. So how to do it? Yeah. Okay, actually very simple. Yeah, work done by force F. Work done by force F. Okay, work done by force F. That means the work done by force F lah. Work done by force F. So it is using F dot S lah. Okay, because it's force F, isn't it? So I just use the force F dot with displacement. Force F dot with displacement. Okay, force F dot with displacement. Just a force dot with displacement. So it's Fs cosine. Work done by force F. Cosine theta. So my force F just now is 49.05. And then the displacement is 20 meter. 20 meter, yeah. And what's the angle between force F and displacement? Force F and displacement. What's the angle? What's the angle between them? 0 degree, because they are same direction, isn't it? Parallel and also same direction. So the angle between them is 0 degree. It is 0. So do you know that cos 0 is equal to 1? Okay. So now continue. Yeah. Okay, I got the answer. The work done is positive. Okay, the work done is positive 981 joule, and it is a positive work done. Okay, that's the work done by force F. Work done by force F. Okay, it's not the net work done. Net work done is equal to 0. But work done by force F is positive 981 joule. Okay, if you want to look further to net work done, is equal to 0. Why? Maybe we can prove it. Prove it whether the net work done equal to 0. Yeah, and see. First of all, we find the work done by gravity. Okay, I do further. Yeah, I do further. Yeah, work done by gravity. Let's find out work done by gravity. Actually, just now the answer until here is okay already. Yeah, this is work done by force F. Now I want to find further. I want to find the, let's say, question C. My question C now is I want to find the total work done. What is the total work done? Okay, I bet that it must be net work done equal to 0. I bet you. I bet you the net work done will be equal to 0. Okay, you don't believe? Let's find out. Okay, let's find out the net work done, the total work done. Okay, this is the total work done. The net work done. Okay, it should be equal to 0. So what you should do is question C. Question C, you find the work done by gravity first. Work done by gravity. So we use the the gravitational force. We use gravitational force dot with displacement. Okay. Now work done by this Fg is actually mg lah. It's actually mg times s cosine. Okay, so what's the angle between the mg with the displacement? The weight and displacement, opposite direction but parallel. That means 180 degree. It is 180. So cosine 180 is -1. Do you see that? Cosine -180. So now let's continue. M is m. What is the mass m? What is the mass m? 5 kilogram. 5 kilogram. So just put 5 kilogram there, and then multiply 9.81, and then displacement is 20 meter. Multiply -1. Okay, cos 180 is -1. Okay, right? So what's the answer for this one? 5 times 9.81 times 20 multiply -1. So it's negative. You see, it is a negative what? Negative 981 joule. You see that? So that means just now our work done by force F. Work done by force F is positive 981 joule. So we can see the effect to the kinetic energy is increase the kinetic energy. It increased the kinetic energy, yeah, because positive work done. Now, how about the work done by gravity? It is a negative work done. Negative work done means what? It decreased the kinetic energy. The gravity decreased the kinetic energy. That means, now let's find out the increase, the amount of increase and the amount of decrease is the same. So the net work done be equal to 0. You see that? So the net work done is we total up all the work done by all forces. So you have two forces, right? You have two forces, the F and the mg. So there are two work done. Well, we have work done by, we have two work done. One is the work done by force F, another one is work done by gravitational force. Maybe you can put this as gravitational force, right? One is work done by force F, one is work done by gravitational force. So let's continue. Just write down. This one is 981 joule. This one also 981. Yeah. Gravitational force also 981, but it's negative. Negative 981. So that's why it's equal to 0. So the change, net work done is the change in kinetic energy, also equal to 0. You see that? So that's why this is about work energy theorem. Later in later subtopic you will learn work energy theorem. Now not yet. Yeah. Work energy theorem. This is what we call. We call it. Let me write it down. Yeah. We call it work energy theorem. This is a work energy theorem. Okay. Work energy theorem. Okay, this is in the final chapter. Final subtopic, you will learn about work energy theorem. Net work done is equal to change of kinetic energy. From the first place, you say constant speed. Yeah, means the change of kinetic energy is 0. The net work done is equal to 0. So I already know the answer for net work done must be 0. Because you say constant speed. That's why after I got the work done by force F, work done by gravitational force, I total them up, I surely get 0. Okay? So what I can say is work done by force F, actually this work done has been, this energy from this work done has been stored in the form of potential energy by gravity. Okay? The work done by force F, when the block is being pulled up, the work done by force F has already stored in the form of gravitational potential energy. Okay, 981 joule has become the potential energy. That's it. Okay, so that's it for this question. Thank you.